All right, guys, we're working on activity 5.2, part A, number 3, geometric constraints. And what we're trying to create here is a set of lines, just two lines, that are constrained in such a fashion that this movement that I'm demonstrating will be in place. I want you to think about what kind of constraints we've done so far and what you think we can use to constrain this. So I'm going to go ahead and go into sketch mode, and I'm just going to snap in two lines that are going to look just like this. I haven't applied any constraints to these two lines, but if you notice, I have the same type of movement occurring. Now I'm going to delete those out, and what I'm going to do now is just draw in two separate lines without them touching. If I move them now, they're not constrained in any fashion. What constraints do we put in place to make these two lines at this point always come in contact with each other? If you said it was the coincident constraint, you would be correct. So if we apply a coincident constraint to those two endpoints, now when we go to move them, you will always get that. Got that one a little crazy. Those degrees of freedom, and they will always stay attached at those 2 points. Right now we are looking at geometric constraint number 2. In this case, we are making a rectangle and a circle so that when I move the outer edge of the rectangle, nothing happens except the rectangle changes its size. If I grab the upper edge of the rectangle will get taller and the circle will get bigger. If I grab the circle, it will adjust the size of the height of that rectangle along with it. And then if I grab the center mark of if I grab the left side of that rectangle, you'll notice that the circle moves along with it. So again, guys, stop, take a moment, and think about what constraints are in play here. So I've gone into sketch mode, and I'm just going to very quickly sketch out a rectangle. The size doesn't matter. And I'm going to very quickly sketch out a circle. Again, the size doesn't matter. Now, right now, this circle and this rectangle are completely independent of each other. Moving or adjusting one has no effect on the other. The first thing I want to do is I want to pin the center mark of this circle to this corner of that rectangle. If you notice, every time I move it, they stay together. So we are going to again use a coincident constraint from that corner of the rectangle to the center of the circle. And it's going to go ahead and right click and hit OK, automatically move that circle in with that rectangle. So we have accomplished this. We're changing the size of the rectangle height. We'll change the location of the circle. Now, the next thing we wanted to be able to do is move the right side of the rectangle and have nothing happen anywhere else. Bonus, we are done with that. So we didn't even need to actually establish anything. But if we change the size of the circle, it has no effect on the rectangle. We want to be able to change the size of the circle and have the rectangle also change its size. So to do that, what constraint did we need to use? We want to attach this edge of the circle to this edge of the rectangle, and we use the coincident constraint. The tangent constraint. So we'll click on that tangent constraint, choose the circle, choose the lower edge, right click and hit OK. Now, if I change the size of my circle, I'm also changing the size of my rectangle. If I move my rectangle, my circle gets larger. So in this case, all we used, I'm going to hit F8 so you can see it. We used a coincident constraint to pin the circle and the corner of the rectangle together. And we used a tangent constraint to adjust the size of the circle to the size height of the rectangle. Hit that F, or just do the hide constraints, and we are back to square one. Okay guys, looking at 5.2 geometric constraint number 3, this is what we're trying to create, this rectangle with a circle and a polygon. If I grab either side, it just gets wider and takes the circle and or polygon along with it. If I grab the bottom, the whole thing moves. If I grab the top, the whole thing moves. If I grab the circle and try to move it, the whole thing gets resized. And the same, if I grab the polygon, the rectangle just gets narrower. So let's start out by modeling our object, and we're just going to build a rectangle, and then I'm just going to put a small circle in it, and then grab a polygon, and we want a 6-sided polygon, and put that in it. All right, so you can see right off the bat, just in the formation of the polygon, we have a coincident constraint at each one of the intersections, and that's so that the polygon can keep its shape. Like, that's what it's supposed to do, right? I can move it around, nothing happens. I can move the circle, it just resizes. So if we want to pin the circle to the rectangle so that they move together, think back, which constraint do we need to use? That's right, we need to use the tangent constraint. So I'm going to click on my tangent constraint, click on my circle, and let's start first by pinning it to the top, and then to the side, and then to the bottom. And it's going to make the rectangle smaller as soon as I do this, which is okay. Go ahead and click OK. I can make my rectangle bigger, and look, my circle is changing sizes with it. I can move the right side and my circle moves with it. Nothing's happening to the polygon yet. Now if I want to tie my polygon to my rectangle, there's a couple of different constraints that I can use, but essentially remember, gents, we're trying to make this line here, the top of the rectangle, and the top edge of the polygon lie along the same line. So we would use our, come on, collinear. So we're making two lines on the same line. So we're just going to choose the collinear constraint, choose the top of the rectangle, the top of the polygon, which is going to move, all right? And then we'll choose the bottom of the polygon and the bottom of the rectangle. The polygon's going to resize, all right? And now we are almost done. The only thing that's left now is I need to tie this point of the polygon to this edge of the rectangle. And because we want 2 points to meet up, I'm going to use collinear again. Just zoom in a little bit. Make sure you hit the point where the two lines come together. So I'm actually going to choose the collinear point already. And then the edge, don't go for the origin point, just go for the edge. And then right click and OK. And now we've got our object. The polygon moves left to right when I pull on the left side. Everything moves up and down when I use the top and the bottom. The circle moves when I move the right side. And then finally, let's make this in a little bit, when I grab the circle, everything resizes. So that's how you do geometric constraint number 3. All right, gents, we are at geometric constraint sample number 4, part of 5.2. What we've got here is an ellipse, a polygon, a square, and a circle. A lot of different movements happen here. I can move the square around left and right, no change. If I move the square up and down, the circle goes with me. So let's start right there. We are going to start out with a square. I'm going to put it right here. And then let's add a circle. I'm just going to go ahead and put it right in the middle. Now, if I want to be able to have the size of the square not change when I move it, I need to make this actually a square and have it be equal on the sides. So I'm going to use the equal constraint, and I'm going to say make the top and the side the same size. And now when I go to move my square, it's resizing, but I still have a square, right? We're going to leave it right there like that. Now I want to also move my circle with me when I move my square. So I need to pin the side of my circle to the side of the square. So again, we'll be using our tangent constraint, top and bottom, okay, only top and bottom, because I want to be able to move the square without moving the circle. If I move the circle, it resizes. Is that what I want to have happen? Yes. Okay. So far I've got this bit right here built. Now we have down here an ellipse with a polygon attached to it. You'll also, well, we'll just focus on that for right now. So let's just make our ellipse. I don't know if you guys have done this yet. So it's underneath of circle. You have the ellipse choice. And what happens when you start to make an ellipse is you draw out a line. So you figure, like, I want my ellipse to be about that long. You click and then pull slightly to the left or right, and your ellipse will form. Doesn't have to be perfect, just snap an ellipse. Okay guys, the next thing we want to do now that we have our ellipse is put in our six-sided polygon. So I'm going to go under this choice and choose polygon. It defaults to six-sided, and just draw myself a little six-sided polygon, right click and hit OK. Now we've got our polygon and we have our ellipse. What I do want to do is have the polygon and the ellipse be centered together on their center point. I could have done this when I built it, but I want to show you how to do it if you didn't build it in that fashion. So we're going to be using our coincident constraint again. So this coincident constraint is this one right here. I'm going to choose that and just click on the center dot of both the polygon and the circle, and it moves that to be centered together. Go ahead and hit OK. So now we're done. Now we go back to our original polygon ellipse. We want to see what type of movement we want. And I want to be able to either grab the ellipse or grab the polygon and have those two move together. Right now, if I grab the ellipse, it's just going to resize, but if I grab the polygon, it sticks together. To pin the polygon to the ellipse so that they don't change sizes, we have to do some constraints. Okay guys, now that I have my ellipse and my polygon pinned together at the center mark, I can drag my ellipse and it will get larger and smaller. Can even change it to a circle and flip it over. If I grab the polygon and move it, the ellipse is moving with it. The next thing I need to do is make it so that I can, when I change the shape or the size of my ellipse, it will also change the shape and size of my polygon. And I'm going to do this by constraining the side edge of my polygon to the ellipse. And we do that using the tangent constraint. So I'm going to choose my tangent constraint, choose on my polygon, my ellipse, then choose the upper side of my polygon, right? And then I'm going to repeat that process again, choose my ellipse and choose the lower side of my polygon. Right now, go ahead and right click and OK. And don't panic the fact that your ellipse is now a circle. I can still change it. Oop, a little too far. I can still make it into an ellipse. That's okay. The next thing I need to do is, if we go back over here to the original one, if I change the shape of, or the size of, say, my circle, it changes the shape of everything. So I need to make the size of one of these edges of my square, which I have connected via a constraint to the circle. So when the circle changes, the side of the square changes its size. I need to make this side equal to one side of the polygon. So I'm going to use the equal constraint and choose the side of the square to the side of the polygon, And now go ahead and click OK. Now when I change the size of one, all four of them are changing. Now this one looks a little bit different than that. We can fix that. There was one last constraint we needed to do. We wanted this corner pinned to the ellipse. So I'm going to zoom in, make sure you get the corner and the ellipse. Zoom back out and hit OK. And now it is the right size, the right shape. If I change the size of this circle, everything squares up. I can move my square left or right. If I move it up and down, that's fine. If I try to move this ellipse, the polygon moves with it. And if I try to resize one of the sizes of my polygon, it changes everything else because this is pinned to the ellipse and the side of the polygon is equal to the side of the square, which is constrained to the circle, so the circle will move and so forth. If you have questions, and this is the most complicated one we've done, let me know. All right, guys, we're on to geometric constraint number 5. This is a triangle with a circle in the middle of it. I'll show you how it's supposed to be able to move. If I grab the top edge of the triangle, it moves. Each other edge moves. If I grab the circle, the triangle will resize. So this one's pretty simple. It's only one constraint. We're going to choose polygon, 3 sides. Make yourself a, let's do it squirrely. Make yourself a triangle, and then let's make ourselves a circle. Now, if we want the triangle oriented the same as this, we can use the horizontal constraint along one of the top edges. It will automatically align it horizontally. And now I want to have the circle pinned to the triangle. So when I change the size of the circle, the triangle will also change. We're just going to use our tangent constraint to each edge of the triangle and on the circle in 3 different points. And you can see there's a tangent on each edge where the circle comes in contact with it. Hit OK. Now, if I grab the upper edge, I can move the triangle. The side, I move the triangle. The side, I move the triangle. Now, when I grab the edge of the circle, it will change its shape. That one was very simple. Let me know if you have any questions.